Because yours. Hello, good people. Hopefully more folks will join us. We're going to have a little bit of a roller coaster ride here tonight. We're talking about the nutrient density of food. Now, I deliberately chose a background today, food 2 hours picking in our garden here. And for 10 years or more, we have measured all the food yield from our garden down to the nearest 100 grams. And then one day somebody said to me, but how nutritious is this food? And then I discovered there were ways of actually measuring this. So it's not just about the weight of the food we produce, it's about how nutritious our food is. We've got a wonderful team of people here with us tonight to talk about that and give us pointers as to how we can check how nutritious our food is. Because we want the world to be well fed. And it's just not just about bulk, it's about vitamins, carbohydrates, all the things that make up food, you know. Food isn't just bulk, it's what it contains. So I'm delighted to have here tonight a team of 4 people to help me. And we're going to start with Elizabeth, who is passionate about good food. And along with the other people we have here tonight, she's an international public health nutrition specialist, a co-founder and director of Growing Real Food for Nutrition CIC, known as Grffn, and that's one of the things you'll hear about tonight, an organisation of people who are passionate about not just quantity but quality. A newly registered award-winning social enterprise, learning how to grow, measure and promote the benefits of nutrient-dense food for better citizen and planetary health. All about connections, not just about us, but about all of planet Earth and all the living beings on it. So over to Elizabeth.
Good evening, everyone. My name is Elizabeth Westerway. My presentation is entitled Nutrient-Dense Food, a Regenerative Solution for People and Planet. The world is experiencing several concurrent emergencies, particularly climate change and biodiversity loss, as well as the often overlooked health emergency. This diagram on the right illustrates the pivotal contribution of biodiversity towards good health and well-being of people and planet, of One Health. However, the worsening biodiversity loss stemming from human separation from nature has resulted in food systems that are not working for people or planet, where people are fed by the food industry, which pays no attention to health, and are treated by the health industry, which pays no attention to food. So as a public health nutrition specialist, I am particularly concerned with the health emergency, worsening levels of malnutrition in all its forms, and the syndemic of diet-related non-communicable diseases such as type 2 diabetes, heart disease, stroke, and certain types of cancers, which are disproportionately impacting disadvantaged individuals, their families and communities, and the healthcare systems that serve them, such as the NHS. To put this into perspective, here are some recent World Health Organization statistics on one diet-related non-communicable disease, that's diabetes, which is now one of the world's most common long-term conditions. The number of people with diabetes rose from 108 million in 1980 to 422 million in 2014. The prevalence has risen more rapidly in low and middle income countries. Diabetes is a major cause of blindness, kidney failure, heart attack, stroke, and lower limb amputations. And between 2000 to 2016, there was a 5% increase in premature mortality from diabetes. And in 2019, an estimated 1.5 million deaths were directly caused by diabetes. In terms of diabetes statistics for the UK, more than 4.9 million people have diabetes, and if nothing changes, 5.5 million will have diabetes by 2030. More than 700 people with diabetes die prematurely every week. The NHS spends at least 10 billion a year, 10 billion pounds a year on diabetes, which is about 10% of its entire budget. Around 90% of people with diabetes have type 2 diabetes, which was previously considered a disease with adult onset. However, more children are now being diagnosed with the condition. 850,000 people are currently living with type 2 diabetes, but are yet to be diagnosed. And research shows that for some people, combined lifestyle interventions, including diet, physical activity, and sustained weight loss, can be effective in reducing the risk of type 2 diabetes by about 50%. Now, the importance of diet for sustainable development was underscored by Grffn and Brundtland over 20 years ago. A safe and nutritionally adequate diet is a basic individual right and an essential condition for sustainable development, especially in developing countries. In 2010, the Food and Agriculture Organization of the United Nations, FAO, developed the concept of sustainable diets, which are protective and respectful of biodiversity and ecosystems, culturally acceptable, accessible, economically fair and affordable, nutritionally adequate, safe and healthy, while optimizing natural and human resources. Hence, FAO defined sustainable diets as diets with low environmental impacts, which contribute to food and nutrition security and to healthy life for present and future generations, thereby respecting planetary boundaries. So our food choices can make a difference to people and nature. Hence, it is important to be aware of and ideally follow the principles of a healthy, balanced, diverse and sustainable diet. Choose sustainable food, so get to know where your food comes from. Consider local and seasonal foods. Eat more plants than animals. Eat a higher proportion of plant-based foods relative to animal-source foods. Eat healthy and minimally processed foods. So look for fresh ingredients where possible. Ensure balance and variety, as too much of any one food won't be good for you or the planet, and eat different food groups and different foods within these groups. Also, check your national dietary guidelines and find sustainable options that fit the health guidance. In the UK, the National Food-Based Dietary Guideline is the Eat Well Guide, which was most recently revised in 2016. If the guidance is to eat more plants, I would like to focus in on fruits and vegetables as a food group and highlight their benefits. It's well known that fruit and vegetables are a rich source of vitamins and minerals and phytonutrients, including antioxidants and polyphenols. Different coloured fruit and vegetables contain different phytonutrients, and phytonutrients can protect tissues and cells from inflammation by helping to regulate immune function. There is an increasing body of research that suggests chronic inflammation can be a major contributor to the development of chronic diseases such as type 2 diabetes. Therefore, the food we eat needs to be as nutrient dense as possible with high levels of phytonutrients. If we consider food as medicine, here are some recent research findings on how fruit and vegetable consumption can impact type 2 diabetes. A 2020 study by Zheng et al. Published in the BMJ, which included over 23,000 people, reported that diets high in fruit and vegetables may help reduce the risk of developing type 2 diabetes by 50%. The study concluded that consumption of even a moderately increased amount of fruit and vegetables could help to prevent the condition. Another 2020 study by Halbus and et al. States that it may be important to emphasize specific subgroups of fruit and vegetables, such as apples, blueberries, grapefruit, grapes, and raisins, to reduce the risk of type 2 diabetes. Now, research is showing that the species of vegetables and the type of cultivars consumed by type 2 diabetics are important for disease reversal. Results of a randomized control trial conducted by Thorup et al. In Denmark, which was recently published in May 2021, shows that traditional cultivars of cabbages and root vegetables, which are rich in bitter and strong-tasting phytochemicals, significantly improve the health status of type 2 diabetes compared with the equivalent modern, mild and sweet-tasting vegetables. So just think of the increased positive health outcomes if all fruit and vegetables are nutrient-dense, packed full of phytonutrients. Interesting connections between plant health, food and human health, as well as soil health and agriculture practices, is increasing. In 2020, Rodale Institute in the USA published their report, The Power of the Plate, the Case for Regenerative Organic Agriculture in Improving Human Nutrition. The report highlighted a prevention-based approach to human and environmental health through an organic, whole foods, plant-forward diet that begins on farms that work in harmony with nature. The report concluded that the link between soil health and human health is largely unexplained, unexplored, and must be advanced. In 2021, the Croatian Institute in the USA published their report, The Regenerative Agriculture and Human Health Nexus, Insights from Field to Body. The report defines regenerative agriculture as agriculture practices that seek to improve the nutritional value of food. It offers a framework for categorizing and better understanding different levels of nutritional interventions, from the most basic level of replacing unhealthy foods with healthy foods, all the way to considering nutrient density and interventions that tend to human microbiomes. The report reflects that growing more nutritious food does influence human health and calls for a new vocabulary, because how we talk about nutrition and nutrients does not yet adequately capture the complexity and dynamism of food. We may never completely understand exactly how nutrient density influences human health, but we know enough to act. So this sentiment of food as medicine is shared by Charles Massey. If people ate truly nutrient-rich food out of healthy soil, you would slash the national bill straight away. Growing real food for nutrition is promoting nutrient-dense food and short local nutrient-dense food supply chains as a regenerative solution to the different global emergencies to improve population health and achievement of the Sustainable Development Goals. The benefits to people and planet of improving nutrition multiplies out across all SDGs. To help build the evidence between soil health, plant health, food, human nutrition, and environmental health, Growing Real Food for Nutrition has been using citizen science. In 2015, the European Citizen Science Association published its 10 principles of citizen science, and I wish to highlight a few key principles. Citizen science actively involves citizens in scientific endeavour that generates new knowledge or understanding. Citizens may act as contributors, collaborators, or as project leads and have a meaningful role in the project. Citizen science projects have a genuine science outcome, such as answering a research question or informing conservation action. Citizen scientists receive feedback from the project, for example, how their data are being used. Citizen science is considered a research approach like any other, with limitations and biases that should be considered and controlled. And citizen science project data and metadata are made publicly available, and where possible, results are published in an open access format. And finally, citizen scientists are acknowledged in project results and publications. So in this way, Grffn has joined a heretofore small, inclusive movement of organisations and leaders working in concert to improve the human condition. Thank you very much.
Always unmute yourself. Thank you very much, Elizabeth. Yeah, there's lots of things there. Sorry, one of the things I forgot to say, people, is if you've got comments back or questions, could you put them in the chat? Because we'll follow up with all the questions at the end rather than in between individual speakers, if that's okay. Thank you. Our next speaker is Matthew Adams. Matthew is a co-founder and director of Growing Real Food for Nutrition CIC. Grffn is the short term. And this is the working group that all this understanding about food nutrition has come out from. And I love the way we get multiply disciplined people with great skills in lots of areas from here, because he's a mechanical engineer by trade. Well, how did he end up worrying about food, you think? And then he got a degree in holistic environmental management, inspired by deep ecology, as many of us have been. He's worked with the Somerset Wildlife Trust, in the Amazon rainforest, and a director of the Good Gardeners Association, promoting no-dig, compost, organic gardening. And now he's going to tell us why that all matters. Thank you, Matthew.
Unmute. Thank you, Graham. Let me just get the slideshow into full screen. Great. So I'd like to welcome you all and thank you for coming to this session. I would like to start with this picture, which is symbolizing the two ways to grow the same plant. And the two ways are connected with something that I'll talk about in a minute more, and that is our worldview. And on the left, we've got growing a plant with under the influence of a disconnected worldview. So we can see the businessman, the accountant, pumping NPK to produce, to increase yield, to increase profit. So that symbolizes our disconnected worldview. And that's pretty much where we are today. And then on the right-hand side is where we want to get to. It's a connected worldview where we begin to understand our relationship with nature. So my slide show doesn't work very well. Right. As a deep ecologist, we are interested in discussing worldview because nobody discusses it. It needs to be brought out in the open. And it began in 1972 with a Norwegian philosopher called Arne Næss, who at the very beginning of the sustainable development process articulated the worldview from the point of shallow ecology versus what he called the deep ecology. And in a nutshell, the dominant worldview that we are influenced by today has been the result of dualism, or separation of the mind and the body. And the result of that has led us to dominantly view the world as a machine. It's a mechanistic worldview. And people call this reductionist. You know, these are words that we use to call the same thing. There's a belief that the world has just been created through a series of random events. And there's an understanding that when you look at nature, what you see is its red in toothing law, and that the survival of the fittest is what rules the day. And so under this kind of belief of how the world works, we've come to try and control nature, and that's where we are today. Really, the human worldview, the dominant worldview, can be seen as trying to control nature. And related to that is how we understand food quality. And as in the picture before, yield and profit is how we measure food quality. Now, the emerging worldview, which is associated with a deeper understanding of how nature works, it suggests that we are nature, we're a part of nature, and therefore if we harm nature, we're actually harming ourselves. Now, this worldview is considered more holistic. You've probably heard of the Gaia theory about self-regulation. It believes that the world is conscious, and we live, therefore, in a conscious world that has a design. We call that conscious evolution. And it's based on the principles of cooperation or symbiosis. And under that worldview, food quality becomes more of a focus on health and nutrition. And hopefully I can expand on that. So I noticed that Elizabeth had a similar slide, and so apologize for that. So I'll scoot over this quite quickly. But this is how I see the environmental impact of our dominant worldview. Biodiversity is down, climate is down, soil health is down. Everything's declining with the health of the planet. And in response to the decline of health in the planet, we also have the increase in malnutrition, degenerative diseases, the number of viruses entering the environment. It's all knocking on the door of humans to say, look, wake up. If you don't look after the planet's not going to look after you. And within all this context, food quality seems to stand as a central, pivotal focus, because under this dominant worldview that we have, food quality has never been defined. It demonstrates a lack of interest or understanding. So I did a review recently to find if there was any definitions of food quality, and in the UK, I'm going to say we completely ignore it. The Food Standards Agency, if you go to their website and tap in the word, nothing comes up. All they're interested in is food safety. And it could be argued that food safety is an issue of food quality. Now in Europe, there's been attempts to define food quality, but it's confusing and definitely not defined. In the United Nations, I've seen there's been work to try and define it. It's evolving, and they talk about taste and nutritional quality, but it's always geared up towards making more profit. And then there's the organic certification. There's been multiple studies over many years to look at the difference between conventional and organically certified food. And whilst evidence is emerging, it fails to convince the powers that be. And without that, nobody is allowed to advertise their food as such. So to evolve this, we need to begin looking at the actual quality of food. And if we could measure the quality of food, the bit that we eat, then we may be able to progress this idea of what food quality is. And I'm going to suggest that we can use simple handheld tools to measure that and understand it. So in the 1970s, Dr. Kerry Reams, a soil scientist and agronomist, he ran a large lab. He spent a whole lifetime studying food and observing food. And the result of that was to produce what he called the BRICS tables, which is a suggested table of food quality. And on a crop by crop basis, he's created BRICS values for poor, average, good, and excellent qualities. When excellent is achieved, he suggests that you will see the complete resistance to pests and disease, increased yield, better taste, and longer shelf life. Now, I've been playing with these tables for a long time, and I'm going to suggest the idea of complete resistance to pests and disease and longer shelf life where the food doesn't rot is actually creating a picture of total health. And along with that is better taste. So we could potentially taste the quality of our food, and that's expressed with a better taste. Now, this clip comes from a session that I did on Radio 4 Today, and I've got this clip here to show you how easy it is to take a Brix value to measure the quality. And here, this is the quality of a carrot.
Well, we're going to do these two carrots, which are different. Simon and I are going to test them.
Yes.
So we've labelled.
Not all carrots are the same.
My
No, not the
picture's
same.
not
No,
moving.
let's
Does
forget the
anybody
labels.
else's
Let's look at what
picture
the
moving?
nutritional value is.
Okay, so I've tasted sample 1.
So sample 1. So I can very quickly test that. At the moment, the tester that I have to cut a slice of carrot, and then I crush it in my pliers, and I put just a few drops of liquid onto the handheld refractometer, close the lid, and there we go. Within about a minute, I'm now taking a reading, and this reading is, I've got a score of 6.
I like sample 2 better.
It
tastes better to me.
Simon, okay, let's go with that. Sample 2 scored a 9, and sample 1 scored a 6.
Is an organic carrot always more nutritious?
There's no guarantee, I'm afraid.
Right, I need to move on because I couldn't see the picture moving there. But in that clip, what I was doing was crushing a carrot to get a few drops of the plant juice, which I put onto the refractometer, which is the picture to the top left. And then you look through the refractometer and there's a scale 0 to 32, and you read off that value. And that value then relates back to the Brix tables. So what I did in that sample, in that clip, was I tested the quality of the carrot, and the one with the higher value is the one that the 2 interviewees picked as the one that they preferred the taste of. Now, what are we measuring with Brix values? We're measuring the products of photosynthesis. So we all understand that plants photosynthesize and they produce basic sugars. But from basic sugars, through enzyme activity, those basic sugars are converted into a whole list of complex compounds, including the vitamins, carbohydrates, and fats, which we identify as nutrients that make us healthy. So in the suggested, associated with the quality of the higher Brix values is the idea of the complete resistance to pests and disease. And Dr. Thomas Dijkstra has spent a lot of time researching Brix values and its relationship to plant health. And this is his summary of that research. And the Brix values running across the top are 1 to 20. And he's determined that when you measure the Brix value of the leaf, you will see the resistance to pests and disease. So we've got aphid groups, stop eating your plant when you have a Brix of between 6 and 8, all the way up to 12 and above, where no pests will attack that plant. That plant is now very high in sugar content, and I can suggest that all that sugar is now being converted into beneficial compounds that the plant uses for natural immunity and to fight pests and disease. Now, interestingly, just a quick touch note on this, all the genetically modified crops that he's tested, he's never found a leaf above 10, which means that genetically modified organisms will continually suffer pests and disease. Now, here's the theory of what's going on, and it's about increasing the efficiency of photosynthesis in the plant. A plant will produce or give up around 50% of that carbohydrate and convert it into plant food, into microbial food that is pushed out through the roots to feed the microbes living in the soil with exudates. So that plant is continually feeding the microbes, which means the microbes proliferate and increase in population very quickly. They help to source the mineral and trace mineral elements that that plant needs and bring it back to the plant roots. So the plant now takes up the minerals that it needs, and it continues to feed the exudates back down to the microbes. So you can see that when this happens, and you're actually beginning to create symbiosis, and that increase in efficiency of photosynthesis means that more sugars and more beneficial compounds are being created. So Grffn, we officially registered in July 2020, and we developed.
Matthew, but we're short of a speaker, so carry on.
Okay, thank you very much. so Grffn, we registered in 2020, and we've been developing some projects around the citizen science, and what we want is to invite anybody who with an interest to get involved and get hold of a bricks measuring kit to begin testing the value of the crops that they're growing. So we've managed to attract 60+ grower partners from across the UK and from the global south, and we're asking them simply just to get used to this equipment and begin to test the quality of, or get the bricks values from the food that they're eating, growing, sorry. Get the values of the food that they're growing, and collate that with taste testing, so that we build out an experience of taste relating to the bricks values. And we're in year 1, and we're just trying to establish a baseline for the quality of food that our grower partners are growing. Now, this was a crop of potatoes that I grew this year. One crop was grown in our research trial garden, which is in year 1, and the second crop to the right was grown in my own home garden, which I've been gardening for many, many years. And I've used exactly the same seed from the same bag, planted in these two different soils. And you can see what's going on in the picture to the right. So the sample A was grown in our research trial garden, and it's year 1, so at the beginning of that journey, and the quality was very, very poor. You can see that from the picture. And then to the right of that picture is those potatoes were grown in my own home garden, and you can see that visually a difference in the quality. And then the results of the bricks value is 4.5 and 6.5 respectively. So this is suggesting a relationship between measuring the bricks value and this incident of pests and disease. So we need to know more, but this is a visual expression of that. Now, the next thing I did was to do taste testing with those same potatoes. So this is a blind taste testing session, and you can see the results, 35 people. So the majority of people did actually select the potatoes with the higher bricks value. So this now is an example of the results that we're collecting from our grower partners, and we've got some target vegetables, but we're encouraging them to just test as much as they can and send in those values. But you can see from the target vegetables that we were looking at, you can begin to see how we are able to place the quality based on the bricks table. To the left of this graph, I've been trying to work out how we can now assess the whole growing operation. So what I've done is for every vegetable tested, I've assigned a value of either 1 if it scored a poor, or a 4 if it scored an excellent. So I can add up those totals, divide it by the number of samples that have been submitted, and that gives me an overall score. So looking at just the top line, we've got an overall score from North Yorkshire of 1.8, and I'm going to suggest that means it's of an average quality. So I'm beginning to assess the whole growing site of that market garden in North Yorkshire. We've obviously got it's taken over an average. So the more samples that are submitted, the higher confidence we'll have in these values. And it's interesting to look down here. We've got some results coming in from South Africa, and you should begin to notice that the quality of that food in South Africa, according to the bricks values, is quite significantly higher. So 2.7 would be in that good category. And what is great about the citizen science is that we can all meet and talk about, well, what have you done to your growing operation? how have you grown your food? And obviously, South Africa is a different climate, and oh no. Okay, I think I've messed up on being muted now.
You're kind of over time here, Matthew.
Oh, okay, sorry. Okay, so I think we're coming to an end then. In conclusion, if we can focus on quality standards based on the idea of total health, then the only way to achieve that is to create a healthy soil, to increase the biodiversity. What we're understanding is that cover cropping is helping to increase that biodiversity, to increase the BRICS values, which together begins to repair the climate. And in return, nature will help us by providing better food, better nutrition from our food. So that helps to build a stronger immune system, reduce malnutrition, and reduce degenerative disease. And that brings me to the end. So thank you very much. If anybody would like to get involved or know more about it, here's our contact details. Thanks.
Well, thank you very much. Lots of great stuff there, Matthew. And I'm sure people who are interested will want to get in touch with Grffn and follow up. Our next speaker is a man very close to my heart. Mark's a container growing enthusiast, keen cook. He says an enthusiastic but very bad dancer. And author of the forthcoming book, which I must tell you is published by Chelsea Green in London. They've now established a UK publishing branch, called The Vertical Veg Guide to Container Gardening. I've been privileged to review it in the making. It's a compendium of great experience, research and recording, which I recommend to anybody interested in growing food, whether or not you're interested in vertical growing. Mark is a very modest person who's an immense fount of wisdom. Mark. You need to unmute yourself.
Thank you, Graham. I don't know if I can follow that. Okay, I'm going to have to first of all try and work out how to share my screen.
That's lovely. You're doing
yes.
Well.
Is that okay? Good.
Yeah,
okay. So I'm going to really report from a sharp end, I guess. I'm one of the growers that Matthew recruited. Well, he didn't really recruit. I actively heard about him and actively sort of signed myself up, I think. And I'm going to share really my first tentative steps into using bricks and what I've learned from it so far. So as Graham kindly said in his introduction, my interest is in container growing food in containers. And it all sort of started when I lived in London and I had a balcony and didn't have any space I couldn't get an allotment. So I thought I'll just try and grow food on my balcony, and was quite surprised to discover that actually I could grow really quite a lot of food. And so really I started Vertical Veg to inspire and support people who don't have gardens to grow sort of meaningful amounts of food in container gardens. And most of them are in the city, but not everybody. And help people overcome. There's lots of great books about gardening, but a lot of them don't address the specific challenges that people face when they're growing in the city. So part of my work is trying to help people overcome those. But I think really what I'm really inspired by is the fact that the potential for people growing at home in containers, how it can change our cities. So for example, this is a very rough ballpark figure, but I think about 40% of most households in most cities In some areas of cities, it's much higher. It's 70, 80, 90% don't have a garden. So the only way they can grow something is in containers. But in my experience, even small container gardens are really good for bringing people together. I think people know that community gardens are really good for bringing people together. But in my experience, container gardening can be at home. So these are people all growing in containers in Newcastle, and we organise meetups where we swap plants, share food, and it's just a great way to bring people together around a shared interest from different communities in the area. You can recycle waste in a wormery, and there's quite a lot of potential, I think, for it to provide source of sort of organic fresh food in areas where a lot of areas of our cities now, it's actually really difficult for people to buy fresh food, particularly affordably. And there is an opportunity, I think, for people to grow some of it themselves at home using containers and to eat better. Many more things as well, but these are just the top things I'm going to mention now. But this is really where my interest in the work of Grffn came in, eating better, because that is obviously a motivation for many people to grow food at home, is to eat better. And I think perhaps arguably the way it can really change the way we eat more than anything is just when you have fresh food on your doorstep, you can basically eat more veg. And that's one of the things, I know, as Elizabeth said in her talk, we primarily need to do is eat more fresh vegetables. And I know since I've been growing, our family eats probably about twice as much as we used to before. But there is interest out there, and I think for good reason, about the nutritional quality of our food has been touched on. And so I was interested to find out, some of the people that I work with are really interested in, does homegrown food in containers, is it what nutritional quality does it have? So a few years ago, I got hold of this book by someone called Steve Solomon, which is a very interesting story about how he grew food in Oregon, and the soil was depleted of quite a lot of nutrients, and he had very bad health issues as a result of that. And then he rectified the soil and felt, and his health returned, which really illustrated to me the power of that good nutritious food can give to you. And as a result of that, I went and bought a Brix meter, which Matthew was just showing us, so that I could measure the nutritional quality of the food that I grew. But, and I think this is probably the case for a lot of people, when they get a new thing and they don't quite know how to use it, I'm afraid to say it sat in my drawer quite unused for about 2 years. Until that is, I met Matthew and Elizabeth and joined the Growing Food, Real Food for Nutrition movement. And this has really given me confidence to take Brix readings. Matthew really showed very clearly how to do that. And having regular meetings with other growers has been a great spur to actually take them. And the meetings have also been a really good opportunity to meet and learn from others. So when you meet someone who says that their rape plants are now at this level of Brix and don't get flea beetle anymore, it's just really great. I mean, we read about this stuff, but it's just really great to hear from someone that is really what is happening. So the question I was trying to find out and ask myself this year was, learn more about, was, can you reuse compost year after year? Because that's something that a lot of us have to do when we're growing in containers, using only sustainable, low-cost inputs, ones that are easily available to people in the city, and achieve high-quality, nutrient-dense food. And the answer to that has a direct bearing on how practical I think this sort of urban growing that I do is. So what I did was I set up 3 containers. This is a really small-scale experiment, not very scientifically, not very statistically valid, but still interesting, I hope, nonetheless. 3 containers, one you can't see, which had new compost, one which had 4-year-old composted wood chip, and I'd actually grown tomatoes in it. This was the 4th year in a row I'd grown tomatoes in it. And one had 4-year-old coir. And obviously the nutrients have been depleted in these, so to replenish the nutrients, I am mulching the top with homemade worm compost. This is my wormery here. In addition to that, I also got a very excellent book by Nigel Palmer called The Regenerative Grower's Guide to Garden Amendments, and made a lot of my own homemade fertilizers, nettle ferment, comfrey, vinegar bone for muscles, all sorts of things. And the great thing about these things that Nigel shares how to make in his book is that they don't smell like a lot of traditional comfrey teas and things smell to high heaven, which is fine at the allotment, but when you're doing it at home in your front garden, it's less popular with neighbours. So these are great, and I use these as foliar feeds on the tomatoes, and also as a root drench. And here the tomatoes are sort of halfway through the season. As you can see, sort of reasonably healthy. But the great thing about the bricks is that I could say to people, oh, I grew them in 4-year-old compost and they grew fine. The great thing about the bricks is that it gives me an ability to measure them. And what I did was I measured the bricks levels in the different composts, and in the 4-year-old compost, actually got the highest reading from a 4-year-old compost for Sungold, 9.5, 8.5 for the wood chip, and 9 for the new. So actually all quite similar. I then grew a different variety, another variety in each container. I should have grown the same variety for comparison, but this was a rookie's mistake. I grew a different variety. So that's not really comparable, except, but it is interesting to note that actually the old compost actually grew, actually had higher bricks than the new stuff. And that's obviously because I've been feeding it, but it just shows, and all the same, the new compost was fed in exactly the same way, but it does just show that it is possible to grow the same quality of food in old compost as in new stuff. And compared to the bricks tables, they cite 4 as being poor for tomatoes, 12 being excellent. So although I've got some way to go to being excellent, in all cases they are relatively good. And I also did measured some Sainsbury's tomatoes at the same time, their best ones. I didn't choose their worst ones, I chose the best ones with a vine on them, and they were 8. So just slightly above. My Sungold are just slightly better than Sainsbury's ones as well. So it's not very scientifically significant, but it does show that it's possible to grow good quality tomatoes in old compost, and that container grown can be as good or even better than supermarket ones. I think the thing which is most useful for me, though, is that if this is a measurement which enables me to back up my observations, because it's one thing to say, oh, it looks like they were doing well, but actually if I've got a measurement, that really helps. The other real benefit of using bricks is that actually once you've bought a bricks meter, and you can get quite cheap ones, it's actually really cheap and quick and easy to measure, in a way that it's not practical for me to send away soil samples and get them analyzed for me. I you know, would be beyond my budget and wouldn't really be practical in a tiny space. But on the other side of things, although it's quick and easy, like anything new, you need to find a way to fit it into your routine, and we've all got too many things to do, and I didn't do as much of it as I would like, so I need to find next year a better way of fitting into the routine. My other finding was that my lettuce readings were terrible. I didn't do any sort of proper experiments with this, but I did read the lettuce a few times, and they were between 1.5 and 4.2. So I was quite pleased to see, Matthew, from your other readings, that most of those were fairly poor as well. But I don't know. But the good thing about this is that knowing this is a real inspiration to me to try and grow it better. So this is where the value of having measurements are. So just to finish off, just to show you the sort of things you can use this for. So although it's sort of about growing more nutritious food, I think it's really useful, interesting about the different ways we can use it. So next year I'm going to use, in this wormery, these are 2 wormeries. This wormery I've been adding rock dust. This one I haven't. So I'm going to grow some tomatoes with worm compost with rock dust, and some tomatoes with worm compost without rock dust, and compare the 2. And that will hopefully give me some indication of whether the rock dust is actually improving the mineral content and the nutritional content of the tomatoes. And that's me.
Well, thank you very much, folks. This has been great. We did expect to have another speaker with us tonight who hasn't shown up. So that's great, because we can have more conversation between all of us.
Graham, Sorry, let me just, excuse me. I do have a couple of slides which I could just show, which is not Dan, but it's related to Dan's work, and it's the Bionutrient Meter. So I could just do a couple of minutes to show you what that is, maybe.
That's good with me, thank you.
Yeah.
Yeah, and Graham, after Matthew has finished, I can show some slides as well. So
Great.
we
We're going
can
to
do
have
that.
lots of conversation between folks, but
Yeah.
there's a few people here now, so let's keep moving. Matthew.
Great. Oh, I need to do share screen again. I must say, I sometimes find this disconcerting because I can't see people at the same time, but let's give it a go.
Very disconcerting, but everybody's hanging on your every word.
Great. Oh, I've got to flip through that. And right, so here we go, Bionutrient Meter. So Dan Kittredge is the chief executive behind the Bionutrient Food Association, and in 2018 they began developing what they call the Bionutrient Meter. So they have been inspired by bricks for a long time, and the idea behind the Bionutrient Meter is to add the next level of information. So the bricks is measuring, you know, a whole lot of things in one measurement. The idea behind the Bionutrient Meter is that samples would be sent to a laboratory and tested for known nutrients in the food, and at the same time scanned using the meter. So they have been measuring lots and lots of samples for polyphenols, antioxidants, proteins, and about 12 or 13 mineral and trace mineral elements. But each sample, interestingly, is sent in with soil as well. So the soil is sampled at the same time, the soil that plant has been grown in. And that's being measured for its carbon content, organic matter, an assessment of microbial life, and again, a whole range of mineral and trace mineral elements. So in 2018, they were testing proof of concept, and they looked at carrots and spinach. So one of the major findings was that in the carrots, the best carrots contain 200 times more antioxidants and polyphenols, which I think is very significant. And this was from around about, I think, 500, 600 samples that were tested. And in iron, they found, these are just examples. So in iron, 14 times more iron in the best samples of spinach compared to all the other samples. And again, there was about 150 to 200 samples that were sent in by citizens, as this is a citizen science project and it's open source. So these were samples from America that were being sent to the lab. Each sample is scanned, and then the laboratory tests them for all these minerals and other things. So having proved the point of concept, 2019, they've increased the number of crops that they want to test, and then year on year that's increasing. So in order to calibrate this scanner, you need to do the lab testing for carrots. And once you've got, let's say, 1,000 samples of carrots, and you understand that there's a lot of nutrient variation within that, each time the carrot comes into the lab and is scanned, it will pick up a unique signature from that carrot. So when you match 1,000 known values of nutrients to the spectral signature, you then have the potential to turn that around so that the scanner then understands what that signature means. So you eventually, once this is fully developed, will be able to have a scanner that you could walk into a supermarket or a farmer's market or your back garden, and you could scan your carrot and find out in real time whether that carrot contained lots of nutrients or an average amount of nutrients, or if it was very poor in nutrients. And as I hope you're picking up on what's being said tonight, this relates to health, and it relates to the health of the soil. It's linking those two things together. So in 2019, they're collecting at the same time a lot of metadata with these samples. So the samples are coming from conventional sources, organically certified sources, from polytunnels, hydroponic systems. And what they found is that the samples coming in from the regenerative practices were above the median for the antioxidants and polyphenols. Now they've began looking at, can they predict nutrient density based on soil health? And there is a relationship is appearing. So here, this graph is showing antioxidants and polyphenols in oats and wheat. It also shows proteins as well. That didn't correlate so well. But what we're looking at here is if you can relate the quality of the food to the quality of the soil, that means that we would be empowered if we had one of these scanners. If you selected food with a high value of nutrients, this is going to tell you that that carrot has been grown in a very, very healthy soil that is drawing down more carbon, and that means increasing life cycles within the soil. Now, finally, this is a picture of the Bionutrient Scanner. This is the development model. It may very well end up as an app on a phone. And if that happens, that will empower anybody with a mobile phone with the scanning capacity to do this themselves. But what they've been finding is that labels like organic or regenerative, it's not always correlating to quality. So these, and this is Dan Kittredge's quote, suggesting that these labels that we put on are all on food. It's all about processes and not about the quality. So where we're trying to go is, let's talk about the quality of the food, the actual bit that we put in our mouth. Right, that's my bit. That's my little bit filling in for Dan.
Yeah, so if I can fill in as well.
Hang on. Thank you very much, Matthew. And I was surprised, this is the first time I used the very simple meter from Grffn and not the one that Dan hasn't sent me yet. You know, the first thing I noticed was commercial carrots from supermarket, Morrison's in this case, scored higher than organic carrots. But one of the things that was pointed out is it depends how long the food has been picked when you process it to check its nutritional value. So there are other things playing around here that affect the food quality. The longer we keep food, the less nutritious it is as well. So Elizabeth, you were going to add something.
Yes, yeah. I noticed some comments in relation to like pastures. So I'll just start off with an anecdote through my tweeting activities. Whenever I see anybody mentions bricks on Twitter, I usually get in contact with them. So beware, if anybody starts getting into bricks, you might have a direct message from me at some point. So I contacted, I thought they were actually a farmer in England. It turned out that the farmer, Netley Farm, is in central Queensland, and they've been using bricks for a number of years as a monitoring tool of their crops that they're feeding their cattle. So they took over this farm about 4 years ago, and they checked bricks values of their sorghum and alfalfa crops, and basically the bricks values were so poor they didn't even register on the bricks table. They were like sub-poor. So over the last 4 years, they've been working with the soil, restoring the soil microorganisms, increasing the quantity and the diversity of the soil microorganisms. And this has been reflected in increased Brix values of their fodder crops. So after 4 years, one of the crops is just about average. The other one, it's still in poor, but it's nearly at average. So bearing in mind, they've still got a long way to go to get those Brix values up to good or excellent. They're really enthusiastic about this. But even so, they've noticed some really significant improvements in their crops, the quality of their crops, and actually the quality of their livestock. The plant health has improved, and they were saying that whereas all the other farmers surrounding them have experienced attack by the fall armyworm, which has devastated their crops, they have had no pest attack. So this sort of equates, mirrors what Matthew has been saying about, increased pest and disease resistance when that Brix improves, and they've been experiencing just at this sort of average level. So they've also shown improvements in the animal health. They put on weight quicker, and generally been healthier, and they've been sated quicker with the food because it's been more nutrient dense. So I asked them if they'd written up this work. They are actually collaborating with the university, so they're undertaking their own citizen science projects as well. So hopefully that will come out later, to testify like what has happened with them regenerating their soil health and then improve their crops and improving their animal health. So that's really exciting. Dan at Bionutrient Institute, they're planning, it's a project that's going to be starting very soon. It's looking at quality of meat, milk and eggs. So again, laboratory analysis to determine how best you grow or rear the food or your livestock chickens to then get that better nutritional quality of the meat, milk and eggs. So I will stop there. Thank you very much.
Thank you very much, Elizabeth. Okay, so open chat time.
There's a question
in the chat. No comments in the chat. I'm just wondering.
There's a question there coming from Bill for Elizabeth on what actual practices were the Aussies doing to improve the Brix scores of their forage crops.
Thank you.
Yeah,
so, Elizabeth.
Yeah, short answer to that. I don't know that level of detail. I will actually follow up with them to find out what precise practices they were doing, but definitely it will be around increasing the soil biology. So getting that increased quantity and diversity of micro organisms in the soil. But thank you for that question.
Bill, you've got your hand up again.
Yes, thanks, Graham. It's a shame that Kylie has left because she too is a livestock farmer, and she had a question about whether Brix would be useful for sampling the vegetation that the livestock were eating. So I gather from what you said, Elizabeth,
used to sample meat.
Yes, well that was my question.
Yes.
Would you actually be able to sample the meat itself or the milk?
Any kind of food product could be sampled, yes.
Yeah, coming back to the pasture, I don't know, have you come across the Soil Mentor app, Bill?
Yes.
Yeah, because that's got Brix on it. And when I spoke to Abby Rose a couple of years ago about this, because I was really excited to learn that she'd incorporated Brix into the Soil Mentor app, she was saying that generally it was, year on year, if you see an improvement in your Brix values, then you know what you're doing to your soils is good, because then you're regenerating that soil biology and it's reflecting in the Brix values.
Yeah, so this is really interesting because I first heard about Brix at a meeting of the Pasture for Life fraternity, and they gave a little demonstration of it. I can't remember who it was, but in the subsequent discussions, and they're a very active community. There's always lots of activity on their WhatsApp group and their Google group. I don't think I've ever heard anyone raise the possibilities about bricks.
I think, Bill, that we have to combine this analysis of food quality with some basic understanding of agricultural practices. So, agricultural advisors in the UK still advise people to plant new lays of Italian ryegrass, plough them in every 3 years. Well, this is just nonsense, isn't it? If you were told to only go and eat bacon, you would die. Why do we want livestock to just eat Italian ryegrass? So we can do some basic things that will improve the health of plant foods for animals, like have permanent lay with multiple grasses and a herbal content.
I think the pasture for life farmers they will have definitely got that message, Graham. And so if you were looking for a community of farmers who were already aligning themselves to start exploring these issues, that would be a good place to start. So one thing I can do is to post the link to this session to the Pasture for Life farming community, and hopefully they will respond and come and explore it for themselves, and we may get some activity going.
The process of understanding that, veterinary bills drop, and then hopefully our food quality measurements rise. So it's a holistic approach. Bricks and all these other things are giving us a measure of the output, but we also do need to be connected with the input as well. Jenny, you haven't said anything. Do you have anything to share? Be nice to hear what you think.
Yeah. Can I comment, Graham?
Well, I was just hoping that our one remaining person apart from Bill might have something to say.
Yeah. No, well, I'd like to just talk a little bit more about the Bionutrient Meter, and because Bionutrient Institute, what they're planning on doing is getting it developed into an app on a smartphone, and this is going to revolutionize food supply chains. The whole idea of this open source citizen science project is to make food supply chains transparent. And so then, having that app on the phone, it's going to be really user friendly for both growers, farmers. So out in the field, they can be testing the quality of their crops, there and then, by sticking that phone next to, say, the carrot that they've just freshly harvested. It's going to be a bit like a traffic light system, potentially, polyphenols being one of the elements that they're going to be looking at. So say if it's red, amber, green, if it comes out red, then as a grower things aren't looking too good if you're trying to be growing higher quality food. Also, food citizens, if they get hold of this app on the phone, they can be going to the shop, the Tesco, farmers market, wherever, picking up the carrot, similarly checking it for polyphenol levels, and if it's a green, then that would be a wise decision to purchase that carrot, because then it'll be improving the health of yourself or your family. If it's a red, again, making an informed choice not to purchase that carrot that is low in nutritional value. So this is all happening. This is going to be coming out in the next year or so, and I think it's going to be really exciting because in real time you can then be assessing the quality of the food that you're either growing or you're about to purchasing prior to purchase. So really empowering for food citizens particularly.
So you won't have to actually squash a sample of the carrot that you're wanting to buy in order to test it.
No, you just go and you pick it up, and that's the beauty of, well, even like the current Bionutrient Meter that you saw in the slides that Matthew presented. You don't have to squash that carrot, and so it's a different process to the bricks, taking the bricks measurements, where you do have to chop off a bit and then squeeze it, squish it with sap pliers, or if you haven't got specially adapted sap pliers that we sell in our bricks kit, or you can purchase on the internet, you can use garlic crusher, but often they're not fit for purpose to try and get juice out of a kale leaf or a cabbage leaf.
There was a few questions came in for Matthew. Matthew, have you picked those up?
No, can you could you
yeah, me or Graham will have them. The first one was with the potato trial. Did you have difference in yields?
I didn't measure the yields. It was sorry, Graham.
You showed pictures of 2 lots of potatoes.
Yes.
They also had difference in yields. I thought.
So I need to just go backtrack and explain a little bit. So we've created this demonstration trial garden where we have 4 areas that are identical, all growing the same crops, but each soil is being treated differently. So we have a control. We're following the method of 2 agronomy services, one that measures the biology in the soil, one which works with the biology and the chemistry in the soil. So we're following these methods. We've got our control plot where nothing's happening, and then we've got a homemade plot where we're making our own biological fertilizers and biochar and affecting the soil in that way. So from our year 1 results, we have measured yield from that garden, but and there were differences, but the soil is very young, shall we say, because it was a flower garden and it hasn't grown vegetables before, so it's in conversion. So I do have results for yield from that, from our demonstration trial garden. But I found that all the potatoes that we grew there were of very low quality. We had a bricks of between 4.5, well, 2 of the plots were 4.5 and 2 of the plots were 5. So there really wasn't much difference going on, but we did observe this difference in yield. But they all generally had suffered in quality. So it's only because I hadn't planned this was serendipitous. Because I had seed left over, I brought them home and put them in my own home garden. And it was in search of looking for this comparison of same seed and to do a taste testing that I used them for the taste testing session. So it's a long, convoluted way of saying no. I don't have a comparative measure of yield. I hadn't set out to do it. Actually, it was a serendipitous event.
Great, thank you. So you said you had another question there.
Yes, it was Bill. You asked a question about were his results published. Was that on the last 2 slides that Matthew did?
Yeah, yes, I'm keen to see that the sources for and Elizabeth's references were on the bottom of the slides, but they weren't visible.
Yeah.
So hopefully we can just catch up with the original sources as well. One other question that just cropped up for Matthew is, are you able to use any animal manures in your composting process, or is it all plant material?
We've used a mulch which is municipal waste, 50% composted wood chip and composted manure. So it's got a 25% mix of well composted manure in it. Yeah, that's
and what source of manure is it?
The The source, I don't know the complete origins. It's from my local garden supplies that mixed the mulch together. So they buy it in bulk, and I've got a few ton from them to use on the garden.
And you probably expect me to say something like this as a livestock farmer, but
yeah,
I've long since thought that there is some vital connection between ruminant manure and the soil, because the gut of ruminants is a microbiome, and it's absolutely awash with microbes. And so it would just be incomprehensible to me that there wasn't a connection between that unit and what's going on in the soil. And I've seen research data to show that.
Point, Bill, and you know, we have this constant sort of battle going on about the moment about the people who think animals shouldn't be used by humans. But if humans don't use them, where are animals going to be on planet Earth, you know? So I think it raises a very important discussion point. Elizabeth's got her hand up.
Yeah, I just wanted to add, Bill, that one of our grower partners, Steve Jones, who's a permaculture teacher. He has been working with Treflack Farm near Oswestry for over 12 years, helping them on their journey of converting from a highly intensive dairy farm now to a regen ag farm. And he does a lot, you know, he has these amazing pies that he sells from the meat. Right. And they are a grower partner of ours, and they've built a mandala garden that is sort of pride of place near the entrance to the farm. Doing citizen science with a permaculture club every Thursday, and the experiment that they're going to be doing in the next growing season is on so they've got the 4 quadrants again, similar to Matthew, but the mandala design is like a sunburst design. So 4 quadrants, so they're going to do no dig versus dig, and then biochar versus no biochar as their experiments. Being on a farm, a working regen ag farm, I think that could be quite interesting for you to just sort of see if they are, you know, how much manure they're using. And then it'll be good to see how their Brix values, what they're showing, you know, down the line.
Yeah, well, the possibilities are endless, really. And, you know, once we get hold of one of these meters, I'm sure we can come up with some trials to run here.
Yeah, that'd be great.
Just on a personal note, Elizabeth, I've been trying to get hold of Steve, who's been in hospital. Have you heard from him?
Oh.
No, okay. Okay.
So he recently won an amazing award. He got Permaculture Magazine award. So that's a real accomplishment.
There was just a question in the chat for Mark. Again, it was from Bill. How did your Brix scores correlate with their taste when you were doing your experiments?
I did taste them, but I didn't really notice a massive correlation. I always find homegrown tomatoes taste so much nicer than shop bought, so I guess I was surprised that there wasn't like a slightly bigger gap between the shop bought ones and the homegrown ones. And I've also noticed that with salads, homegrown salads often a fantastic flavor, but the Brix is often low. So I haven't really quite got to grips with the correlation between Brix and flavor yet.
I'll just chip in there, because I have now tested literally hundreds of vegetables for Brix and tasted quite a lot of that in the process. So it's not always easy. Lettuce is a poor example, because I think I've seen one lettuce that has escaped into the average category. Everything that's been tested has been very poor. Now, that might be a reflection on the Brix values in the first place, and so we can question that. But a lot of the crops that I have tasted, where I found 3 or 4 things that are excellent, and I can assure you that the taste was amazing. And because I've tested so many vegetables, and they represent those categories: poor, average, good, and excellent, I feel like my own personal experience, I am seeing that relationship between the higher Brix value and the better taste.
Is it possible, Matthew, that lettuce, if you looked at the entire range of lettuce, it would be at the lower end of the Brix scale, whereas other, maybe spinach, would be in a region that was higher, because it is a darker color anyway, and that may just be the way they score.
It may just be the way they score. Absolutely right, because you have to take this on a plant by plant basis. And I mean, I flashed up the Brix tables, but if I was to go back to those and point out, you'll see that apples, for example, those Brix values are specific to apples, and apples are very high in sugar, so the values are 10, 12, 14, 18. Whereas lettuce, the values would be 3, 5, 7, 9. Lower generally. So the spinach, interestingly, is also quite low, but I'm seeing the average Brix values of spinach as being slightly higher than the lettuce. So your thinking is correct with that sort of deeper green. But it gives us the opportunity and empowerment to start testing varieties of lettuce and soil conditions of lettuce. And this touches on your points about the cow manure. If you've got this very crude way of measuring food quality, you can put it to the test. You can begin to answer your own questions. And this is what we got from Mark. Mark is starting to get what's going on here. And so you can start testing ideas without that huge cost of sending it to a laboratory where you get back a whole bunch of results that can be quite confusing. So it's a great way of assessing, and it's a great way of beginning to answer some of your own questions that you generate.
Thank you, people. Time to wind up now. First of all, Elizabeth, I believe you have a parting message for us.
Yes, I do. This is like the pre-parting message, Graham. So, I just wanted to highlight Grfn's 4 key advocacy messages. It'd be great if other people would like to also start advocating for these messages. So the first one is shifting the narrative from food quantity based on yield to food quality based on nutrient density. That's really important, if we're going to be improving population health. So the second one is shifting the narrative from food security to nutrition security. And in the references, when you get them, definitely share them, Bill. So it will be slide 16. I've included a link to a recent article that was published in April 21 from Tufts University in the States. And it's entitled Time to Shift from Food Security to Nutrition Security to Increase Health and Wellbeing. The article argues that today's health and equity challenges call for the US to shift from food insecurity to nutrition security in order to catalyse appropriate focus and policies on access not just to food, but to healthy, nourishing food. So that's a big difference. And that brings us into the third key advocacy message, is to start talking about the right, not just to food, but to nutritious food. So getting that element of quality in there, food quality. And the fourth key advocacy message is it's around using food as medicine to reverse and prevent diet-related non-communicable diseases, such as the type 2 diabetes, which is having such a devastating impact on individuals, families, communities, and the NHS. And that's just one of those diet-related non-communicable diseases. And also, if we do that, then we're going to break the power dynamic of big ag, big food, and big pharmaceutical. So there we go. So that's it from my
Thank you,
message.
Matthew. Your one sentence parting gift for people.
My parting gift is to consider food quality as a way of developing a deeper relationship with the world around us, the natural world.
Mark, your parting gift. Unmuted.
Yeah, sorry. Mine would be that I started off this around measuring nutrition, and I think it's very useful for that, but I think it's also a way of measuring the health of plants. Brix is a way of measuring the health of plants and doing really simple comparative tests to see what works, what makes a difference and what doesn't.
And my parting gift, people, is to thank you for listening to this. Not that many people turned up to this event, but in sociocracy, one of my favorite ways of managing things better, they say the right people who turn up are the right people, you know? This is recorded, and for those of you who are also coming to join us, can I bless you for listening to this conversation? It's not immediately entertaining food nutrition, but it's vitally important for the survival of the human race. And so many people in so many places are so challenged with their nutrition that the more we can focus in on this vital subject, the more we have a chance to make people's lives better. I commend to you the rest of this course, symposium, whatever you want to think of it as, for the many great events going on here. And I do encourage you to keep engaging with the Northern Real Farming Conference and with all your friends and with all your people, and to grow food and share it in a loving way.
Will do.
Thank you very much. That's excellent. I'll stop the recording now.